Now we have a better understanding of elasticity and scalability. I am taking a little tangent and talking about load balancing. This is also one of the very important aspects when we implement scalability and elasticity. We still want to distribute loads evenly for the resources, and that is where load balancing helps us out. So we'll talk about what is load balancing in general, and we'll see implementation detail of it into AWS context. Right. So load balancing is the method of distributing network traffic equally across pool of resources that support an application. Simple idea is I may have multiple resources behind the scene and they all need to receive request. That can be done by a load balancer here. This load balancer would use some algorithm to forward traffic to those locations. Now it is just kind of a forwarder. It is not able to store any information. As soon as request comes, it would identify some parameters of the request and based on that forward it to the back-end services which we are running. We will discuss more in detail how this forwarding work, what can be running into the backend, but this is what a load balancer work is. Receive request, identify where it has to go and forward it, but do not store any information in this particular place. So this device basically sits between your user and server group. It acts as an invisible facilitator. It ensures all resources servers are used equally. That's what it is doing. It is load balancing, ensuring that not one server gets too much utilization and other server are sitting idle and doing nothing. That would be uneven distribution. So that is the use of load balancer. Now load balancer is not a cloud specific term. It exists in on-prem world also from long time. And when it comes to implementation, these can be implemented through a hardware-based load balancer or could be a software-based load balancer. Hardware-based load balancer are physical devices which you would commission into a data center, configure it with an interface, have cable connectivity, and they would start distribution of the load. On the other hand, software-based load balancer is where you deploy a operating system which would have load balancing software like BalanceNG, HA proxy, and that would allow you to distribute the load. Concepts remain the same. Sometimes it may be preferable to use hardware based load balancer because of the physical requirement you may have, or software would be giving you more flexibility if you want to have multiple deployment done and maybe run as a virtual appliance. So software can be a better approach. So question comes how AWS allows me to use load balancer and why I would be using load balancer, what context we use load balancer in AWS. Let's talk about it. First thing is load balancer in AWS can help me in achieving a highly available architecture. What I could do, like you see here, I am running my application services maybe in AZ-A and AZ-B, availability zone A, availability zone B. And I have one single interface which is receiving request and then forwarding request to respective availability zone. So the better benefit here is even if AZ-B goes down, I'm not completely out of my applications activities. I can still have the traffic being forwarded to AZ-A and respond from it. I have just implemented 2 AZ architecture, but you could go to 3 AZ or even 4 or 6 AZ provided your region has that many AZs. So that is one option. So health high availability can be used with that. Second benefit we get is health check. Obviously, we don't want to send requests to unhealthy target. Now that unhealthy can be due to multiple reasons. Maybe the software has failed, maybe a service has failed inside, or maybe the instance is right now booting up and not ready to receive the request. So load balancer can perform health check and it can then decide, okay, one of the instances behind the scene is not responding to my health check. Let me not forward traffic considering it is an unhealthy instance and request may not be fulfilled properly by that unhealthy instance. So that can be done. It can identify and then balance the load. Now, if this was healthy initially, this instance, then maybe 33% traffic, 33% traffic, 33% traffic is going here. But as soon as this is detected as unhealthy, obviously it would be then saying, okay, I have to redistribute and maybe 50% traffic goes to my instance A and instance B in this particular case. Another benefit we achieve by using load balancer in our AWS architecture is security. If let's say I have services which are like web server which I want to be accessed by public. If you do not have load balancer, then you have to expose your servers directly to public subnets. But what I see here, I could have implemented architecture where my load balancer is exposed to public subnet, but I'm still keeping my web server into a private subnet, giving me additional layer of security, or I'm hiding away all the public facing servers behind public subnet which are running in private, and only load balancer is exposed and it is managed service. It can be integrated with other services. We will discuss them like web application firewall. So it would protect from common DDoS attack which may happen. This is optional, but you could also integrate it. Even if you do not integrate WAF, you are still getting protection of running your web server into a private subnet and not exposing those servers to general public. One more benefit I want to discuss here is the TLS termination. TLS is your transport layer security. We all know HTTP and HTTPS are two methods of communication. HTTPS is secure, which will use encryption, and when an encryption is being used, it would require some CPU utilization or memory utilization on your backend. So whatever these servers capabilities are, maybe 10% of that is going into this encryption algorithm monitoring and all type of stuff. What we could do, we could say we would offload that request to load balancer. When a user would initiate request to my application till the load balancer, it would be received in HTTPS. This would ensure that requests are encrypted while it is in transit, and these behind the scenes servers are internal. And if I want, I could say I don't want to keep on using HTTPS behind the scene. I want those requests to be in HTTP so that I do not have to sacrifice additional CPU and memory from my instances to perform security. Now it is hidden and we are just using HTTP to communicate to it. So this is how you could implement load balancer. So these are some of the benefit you would achieve once you start incorporating load balancing services in AWS. We will talk in detail now what are the different options available for us. Services we call here is Elastic Load Balancer, or in short we call it ELB, and it is a group of service in which we have multiple type of load balancer. So I'll talk about them in the next slide. So when we start about implementing, we offer AWS offers this service as a managed service called Elastic Load Balancing, and there are 4 different type of load balancers you could deploy depending on your business and application need. The oldest existing one is a classic load balancer. It still exists for maintaining backward compatibility, but may not be very useful in most cases. We would still be keeping it here, but we will not be discussing in detail about classic load balancer. The common ones are application load balancer, network load balancer, and then a recent addition is a gateway load balancer. So I'll talk about them. I would first talk about these two which are very commonly used, and then I will address gateway load balancer as a completely independent topic. Why we have different type of load balancer? Because we may have different type of targets to support to. Target are the destination where the request will be forwarded by the load balancer, and this target can be running and addressing through different protocol. So these load balancers support different protocol. I'll talk about them as we move forward, and there is no upfront cost to manage these services. AWS would take care of deploying it when you need it, and you will only pay when you actually use it. Otherwise, you do not have to keep on services running if you do not need them. Right, so this is just some of the load balancing fact into AWS. Let me now start focusing on first two, which is application and network load balancer. I'll talk about differences between them, and we will see implementation of these into the next section. So I'm comparing here application load balancer and network load balancer. Now, how they decide and when to use which one to be incorporated in your architecture would require you to understand a little bit on the OSI side of networking. OSI stands for Open System Interconnection, and it is a common theoretical model by which all network communication actually happens. It is theoretical, but it has divided the network communication into 7 layers, and those 7 layers ensure that we are able to create interoperable application, we standardize the interfaces, we reduce the complexity, and every application protocol, or sorry, every protocol works expected to work at a specific layer. Like HTTP and HTTPS protocol, they would be working on application layer. Then we have a protocol like TCP, which is considered to be working on transport, and network, which is considered to be working on IP layer. This is a theoretical model. It is not actually implemented into real life, but every networking discussion initially start with OSI, and that's why we would also take this into consideration when we decide when to use an application load balancer or when to use a network load balancer, because sometimes they are also referred at the layers which they operate. So sometimes you may hear people saying we have a layer 7 load balancer, or sometimes somebody would say we have a layer 3 load balancer, and that's why I just wanted to highlight here that these layers are coming from OSI model. Okay. Let's keep on discussing, and let me use an analogy to explain the concept of forwarding traffic. Let's say we have a king, and the king would be getting lots of letters, right? So maybe king of England, Prince Charles, they now King Charles, he is receiving lots and lots of letters, right? People would be writing him to invite him to marriage, weddings, and maybe to a birthday party or whatever, could be anything, or to give donation or something, but he may not have time to read everything, right? So what he might have done, he might have appointed a secretary, and letters which are coming, I'm talking about the physical post, those letters are first going through the secretary, and then only when she finds something useful for king or something which should be addressed, maybe then forwarded to king. Now I'm keeping it simple, but what may happen that this secretary may be working for other members of the royal family also, and when she receives a letter, she would identify how to forward that letter or the information within that letter to that particular royal member. Like right now, I'm just keeping king here as a discussion point. So when a letter comes, she has to decide on filtering those letters. One option for her to filter is that she can read the header information on the letter. Every letter would have to and from information, so she can identify that who has sent this. So let's say this letter has come from Ashish, and she doesn't know who this person is. Obviously that letter may not be reaching up to the king, but if something comes from, let's say, Duke of Edinburgh, then probably it has to be reaching to the king also. So that's what one option of filtering is, basically a filter based on header information which is outside of it. Think of it, when your communication happens, whatever data you want to transfer, the data is encapsulated by additional information that we call header. Right. So this header would have information like what is the source IP, what is the destination IP I'm going to, port number details, protocol type, that will all be into the header. So that information is being read by load balancer, like in this case secretary, and she would then forward that information to king. So this is one criteria of filtering. We can filter based on header information of the packet. But again, somebody would have lot of data, a lot of letter would still be reaching out to the king. So what king may have given permission to the secretary that, hey, I am giving you permission to open the letter and read the content of the letter and then only forward me the required information. So king authorized this secretary to open the letters addressed to him and read the content of the letter, and if it is relevant then only forward it. So now the filtering will be based on the content, not just the header information. What you just saw here is a application layer filtering. So when your data is inside this packet, so this is my data, and on top of it I have my header. If I am taking care of forwarding purely based on header, that is my network layer forwarding. What I am doing here right now, I am utilizing a data to be making the forwarding decision. So we read the content, we read the actual data, the request, and based on that we forward that. So that is application layer forwarding or application layer load balancing. And here the bottom one, the header, is a network layer load balancing. So I hope this thing is clear. An application layer is considered layer 7 in OSI model. Network layer is considered layer 3 into OSI model, and that's why load balancer are also referred with those information. So first difference between an application and a network load balancer is application load balancer operates at the request level, the data level. It is operating on application layer or what we call layer 7. On the other hand, network load balancer is operating on a connection level, which is your IP information or a header information on the network layer, and it is called layer 3 load balancer also. So decision to route traffic to a specific destination in an application load balancer, it is based on the content of the packet. In network load balancer, that information is forwarded based on the header of the packet, the outer information of the packet itself. Supported protocol, that what can be the form of request or protocol we would be able to identify when it comes to your application load balancer. The request from internet client can come on HTTP or HTTPS, and then we can also have backend responding on HTTP, HTTPS. We have one more protocol here which is gRPC. We will talk about it when the time comes, but yes, common one is HTTP and HTTPS. On the other hand, when it is about your network load balancer, it supports TCP, UDP, and TLS, which stand for Transport Layer Security. TCP stand for Transmission Control Protocol. UDP stand for User Datagram Protocol. So my request to this load balancer can be coming in any of these protocol, and at the back end we will forward it to those by TCP or UDP communication. So that's how your forwarding of the request would be working. Another major difference between application and network load balancer is the use of static and elastic IPs. Application load balancer would not be providing a static IP. Its IP address would be changed. What application load balancer will be providing you is a DNS name, not a static IP or not an elastic IP association. So we would get a DNS name and we would always request data from this load balancer using the DNS name. On the other hand, network load balancer would be providing a static and elastic IP as it is mentioned in this slide. Alright. Last difference here, that how we will forward or who would receive the traffic at the backend. That traffic would be received by something what we call as a target. So targets would allow me to receive traffic. That will be different types. Application load balancer support instances, which is EC2, containers running on different platform ECS, EKS, and Lambda function as well as IP addresses. These are valid target for application load balancer. For network load balancer, everything remains same except a Lambda function. So network load balancer can also forward traffic to instances, containers, and IP addresses, but not to Lambda function. I hope everything is okay and you are following along. So hope you got an idea of application and network load balancer. In the next section, I would show you a demo of how application load balancer is configured, and we will talk about some of the terminologies associated with like listener, target group, how to configure health check. So we'll talk about that. So I hope to see you into next section. Thank you.